Hi class, the question my group and I have came up with is the crew of a dragon boat is in a river at point 1 where the river is 5 meters wide and 2 meters deep with water moving 1 millisecond. The crew's rowing adds 3 milliseconds of speed to the speed of the water. As the boat moves downstream to point 2, the river broadens to 10 meters wide and 4 meters deep. Assume the water in the river is incompressible and so has a constant density. Part A. What is the new speed of the river? Part B. By how much of the rowers have to increase their rowing speed to maintain the same speed of the boat? How to solve the problem. To solve this problem, we need the equation of continuity. P1A1 V1 equals P2A2 V2, where P equals the density of the fluid in this case water, A the area of the fluid passes through at a given point, and V the velocity of the fluid. However, because we assume the water is incompressible, as most fluids are, P1 equals P2, and our new equation of continuously is A1 V1 equals A2 V2. The data that we already know is the area of the water passes through at point 1 of A1, which is at 5 meters times 2 meters, so an area of 10 meters squared. We also know that the area of the water passes through at point 2, or A2, is 10 meters times 4 meters, which gives an area of 40 meters squared. The third variable we have to have is the speed of the river at point 1, or V1, which is 1 meter squared. By plugging these variables into our new equation of continually, we can solve the V4, V2. The new speed of the river at point 2. Our calculations show that the new speed of the river is 0.25 meters squared. A sample edition shows that the boat's initial speed of boat O is 4 meters squared when the speed of the crew is added to the speed of the river. Because we want the same speed of the boat, points V, boat F, the final speed of the boat should also be 4 meters squared. Now we set V, boat F equal to the sum of the new speed of the river, V2, and the new rowing speed of the crew, V, crew F. More simple math, and we find the new rowing speed of the crew to be 3.75 meters squared. Finally, when comparing the new rowing speed of 3.75 meters squared to the initial rowing speed of 3 meters squared, we can find the difference between the values to be 0.75 meters squared, which is the increase in rowing speed needed to maintain the speed of the boat.